In the previous episode, we talked about vertical addition and subtraction in IBI, which is done similarly to addition and subtraction in decimal. Likewise, vertical multiplication in IBI is done almost exactly the same way as in decimal. We will take a look at an example of IBI multiplication in two different ways. First, in standard notation, and second, in negative notation. Let's try I1, I0 times I1, I1, which is the same as 2 times 3 in decimal. But of course, since there are more digits, it's not quite as simple. Just like in decimal multiplication, we start with the rightmost digit of the second factor and multiply it by the first factor. In this case, the digit is 1, so we just put I1, I0 below the line. We then shift one place to the left and continue our multiplication process. This time, we have I times I1, I0. I times 0 is 0. I times I is negative 1. I times 1 is I. And I times I again is negative 1. We will keep the negative notation for now and simply put negative 1, I, negative 1, 0 down. We then have another 1, so we shift left and put down another I1, I0. Finally, we have another case of I times I1, I0, so we shift left and put down negative 1, I, negative 1, 0. Now we add everything together. In our first column, we only have 0, so we just write down the 0 again under the dotted line. In the next column, we have I plus 0 equals I, so we write down an I. Then, we have 1 plus negative 1 equals 0, so we're left with 0. In the next column, we have I plus I, which, using the carrying over rules from the previous episode, leaves an I and carries a 1. The fifth column then becomes 1 plus negative 1 plus 1 plus negative 1, so we're left with 0 again. In the sixth column, we have I plus I, which leaves a 0 and carries a 1. Finally, we have 1 plus negative 1, which leaves 0 again. Our first three digits are zeros, so we can remove them and we are left with I0, I0, or 6 in decimal, which is the correct answer. However, converting the factors to negative notation often allows the problem to be solved more quickly. The final product must be converted back to standard notation. Let's take a look at the same problem above, I1, I0 times I1, I1, but in negative notation. Although there are a couple different ways to convert a number into NN, the easiest in this case is to change the I1I in both factors into negative I. Our problem now looks like negative I0 times negative I1. Immediately, we notice that there are less digits involved, so we can predict that the multiplication will be more straightforward. First, we take the 1 from negative I1 and multiply with negative I0 to get negative I0. Then we shift left and do negative I times negative I0 to get negative 1, 0. To get our final answer in Sn, we turn the negative I back into I1I, which cancels out with the negative 1, and we're left with I0, I0, just like before. This time, we got to our answer much faster. The reason that using NN in multiplication is faster is that it usually decreases the number of digits in the factors and eliminates the need for extra canceling. In the first example, there were 3 extraneous zeros in front of the answer. Those zeros didn't appear when negative notation was used. It is good practice to always convert a multiplication problem into NN, since converting from Sn to NN is generally not too hard. To keep things simple, change any instances of I1I into negative I and any instances of I1 into negative 1. This will often make the multiplication problem easier and will certainly not make it harder. Thank you for watching the 5th episode in our series on IBI. We hope you enjoyed and stay tuned for more to come. If you want to review how conversions work, feel free to check out episode 2 of this series, titled Standard and Negative Notation.